Hello there, children. Today we are going to work on section 7.5, graphing square and cube roots. This educational experience is brought to you by your super cool rector of square and cube roots. That would be me, Mr. Faust. So let's start here. So, what do these things actually look like? So remember from earlier this year, a square root is something whose index is 2. Now, we don't write the index when it's 2. Remember that. A cube root, it has an index of 3, almost like a cube function. We'll get to that in a little bit. Now the question is, what do these graphs actually look like? So let's start off with the square root. Square root is something you may have seen before, so it's something we are going to be able to go over. So let's take a peek at what a square root looks like. Now, a square root looks like this. It has a domain of x greater than or equal to 0, y greater than or equal to 0. Now the question becomes, why don't we have negative x values? And as you probably should remember, can I have a negative square root? No. So there are two key points that we are going to need to worry about. And as you can see there down here, one of them is the point 0, 0. Remember that this is x, the first coordinate, and the second coordinate is y. The reason I have this is, what's the square root of 0? If I put x to be 0 in here, I get back 0 for y. The other key important point that we have is going to be the point 1, 1. What is the square root of 1? It's 1. Now you're like, well, why don't I make a t-chart, Mr. Faust? That would be super helpful for us. Here's the problem. I know that these are two nice and clean points here. But what happens at like x to be 2, for instance? Well, what's the square root of 2? I know it's a number. If I put 2 in for x, I get a number back that's between 1 and 2. Do I know what that exact number is without a calculator? No. So that's why that number isn't that helpful. So every time you graph a square root, you are going to graph 0, 0 and 1, 1, or the transformed version of that. We can't have a negative square root, which is why the domain, remember that's x values, is greater than or equal to 0. My range is y greater than or equal to 0 here. So it's a little curve like that, and it goes on. Now, what does a cube root look like? Now, a cube root function here looks like this, where the domain and range are all real numbers. Now, the question I have is, why does it look like this? Well, remember, cube root has the index of 3. Well, let's look here. Can I have negatives? Unlike a square root, I am allowed to have a negative cube root. That's okay for me to have, which is awesome, which is why my graph goes in both directions. It also means for my key points over here, I'm going to have 3 of them. Now, you're probably thinking to yourself, Mr. Faust, it has 2 of the same points as the square root does. You're correct. I am going to put x to be 1 in, because what's the cube root of 1? Or what to the third power gets you 1? 1. That's where 1, 1 comes from. What is the cube root of 0? What to the third power gets me 0 for x? There'll be a 0 for y. But along with that, since I have this cube here, I am also able to put negative 1 in here, because what to the third power gets me negative 1, negative 1. So cube roots go in both directions. The domain and range, this is really important, is all real numbers. So my domain and range here are going to be all real numbers. That means that it doesn't matter where this function moves, and yes, we're going to move these functions, it's still going to be all real numbers all the time. So now, how are we going to graph these things? Well, they follow the transformations that we have for other graphs, which we've done the entire year. So just so you're aware, these graphs do follow transformations that we have done all year long. So our graphing rules. Now again, we've done these for a while, so we're going to take a minute and go through them. So here is what those rules are. Take a minute to write them down, and we'll go over them. So what does this all mean? Well, to graph any function, remember, this H and K transformation, probably like, I've seen that before. And you have when we graphed squares, and we graphed cubes, and we graphed absolute values, and we graphed other equations this year. We talked about H and K. This isn't anything new. So, first off, sketch the graph. That means the first step is identify which one you have, whether it be a square root, which is this one, or a cube root, which is this one. Now, shift the graph horizontally with H, remember opposite on the inside, and the K units vertically. And you're like, that makes no sense. This is what you have. You're going to graph your key points, adjusting them with the Y values, which are your K values, and the H values, which are going to change your X's. Let's go through an example here. So here's my example. First off, this is a square root. How could I tell? The index up here is 2. If there were a 3 there, it would be a cube root. Now, since it is a square root, I am going to try to graph the points 0, 0, and 1, 1. But this graph is transformed. So what does this actually mean for us? Well, let's look here. This value on the outside, this 2. That 2 is going to change what? That's vertical. Vertical deals with Y. So whatever this number happens to be, you are going to add that number to your Y values. So instead of a 0 here, I'm going to have a 2. And instead of a 1, I'm going to have a 3. Now, this value, this 1, the rules are opposite on the inside. So it looks like a -1 here. You are actually going to add 1. Do the opposite operation there. So instead of having a 0, you're going to have a 1. Instead of having a 1, you're going to have a 2. So to recap, this is your Y value on the outside here. Whatever that value is, you simply add that function, or add that to your function. Meaning, you simply take this value and add it to your Y values. So instead of a 0, 0 plus 2 is 2. Instead of a 1, 1 plus 2 is 3. The inside number, it's opposite on the inside. Instead of subtracting 1, you're going to be adding 1. So 0 plus 1 is 1, 1 plus 1 is 2. Let's go through another. Wait, we haven't graphed it yet. All I do is plot these 2 points, and you're like, okay, then what? Just draw a nice smooth curve. Folks, these graphs, I'm not looking for Rembrandt-like work. You need to have these 2 points. You're going to have to label them like I have them over here. You must tell me what those points are. Plot them. 1 for X, 2 for Y. And then this point, 2 for X, 3 for Y. You plot that point and just draw a smooth curve. The reason I don't have anything over here is because it's a square root. You don't have an arrow here, you have a dot. If you put an arrow, it's incorrect. Let's keep going. Now I need to identify here. Which one is this? It's a cube root. How could I tell? The index is going to be a 3. Now, let's talk about this. If it's a cube root, I have 3 points. 1, 1, 0, 0, and I also include the point -1, -1. You do have to know those, folks. So a cube root, think of the index of 3, 3 points I have to graph. When it's a square root, the index of 2, I'm graphing 2 points. Now, back to these transformations. This one on the outside. What does it do? Well, like it's done all year, I simply take this number and add it to my Y values. And you're like, Mr. Faust, you're adding a -1. Wouldn't that be subtracting? Correct, it would. So instead of a 1, 1 plus a -1 or -1 is 0. 0 plus a -1 is -1. Then -1 minus 1, or -1 plus a -1, -2. Now, this number, it's opposite on the inside. So technically you're like, I want to be adding 2. You're actually going to do the opposite. If you want to think of subtracting on the inside, because 1 minus 2, that's what you're doing. 1 minus 2 is -1. 0 minus 2, negative 2. And again, I'm doing the opposite because it's on the inside, just like we've done all year. Negative 1 plus a negative 2, negative 3. So again, you do the opposite. It's a positive. I'm technically subtracting. Now I plot these points. Why does my graph go in both directions? Because I'm allowed to have a negative due to that cube root. All right. Moving on. I'll give you a couple seconds on this problem to identify it and talk about the points in the graph. Now, what is this graph doing? Well, it's a square root because I've got no index written there, so it's 2. Now, I know this transformation on the outside is going to be going down 2 units. This transformation inside, opposite, so it's negative. I'm going to be going to the right 2 units. Now, where did I get these points from? Remember, I took my original points, which, in case you forgot, are 0, 0, and 1, 1. And I took those points and did the following. If I'm going to go down 2 units here, like this, that's going to make those negative 2 and negative 1, because I'm essentially adding a negative 2. And on the inside, remember, it's opposite. So you're like, oh, it's subtraction. You're actually going to be adding here. Opposite on the inside, the same way we've done it literally all year for all the other graphs that we've done when we had vertex form of anything. So there are my coordinates. All right, moving on. So I'll give you a second to try this one here. Identify what type it is and what points we need. Now, you probably realize it's a square root because my index is 2 there. It's not written. However, is there any vertical transformation out here? No! Correct, imaginary voice in my head, there is not. So since there is no vertical transformation, what's going to happen to my points looks like this. I still graph 0, 0, and 1, 1. The y values don't change. They're still going to be 0 and 1 because I have nothing out here to transform them. Now on the inside, it's a plus, which means I'm subtracting 3 from my x values. So 0 minus 3, negative 3. 1 minus 3, negative 2. Then I plot these points. Negative 3 comma 0 is right there. Negative 2 comma 1 right there. Nice smooth curve up like that. Why don't I go down the other direction? Because it's a square root. Square roots stop. Think of squares and stopping. They stop at one end. This is pretty much it for this section. Now, what is the domain here? You could ask yourself that. The domain of this is x's greater than or equal to negative 3. Remember, x's are all possible x values. So talk here and think, wait, this domain is starting right there. So that means negative 3 going on forever. What's my range? My range, my y values start at 0 and they go up forever. You are now ready to tackle this section. Go henceforth and do.